What is the 2's complement of the following binary number? To make it easier, I'm going to change the colours of the bits, and I'm now going to change all of the 1s to 0s, and I'm going to change all of the 0s to 1s. So what you now can see, we have this original number, and we have this, which is the 1's complement. The next step is to add 1 to the 1's complement. 0 plus 1 is 1. 1 plus 0, because there's really 0 here, is 1. 0 plus 0 is 0. 0 plus 0 is 0. If you look at these three, you can see they've effectively been copied down. Consequently, these will be copied down. And what we have here is the 2's complement. So we can see that this was the original number. This is the 1's complement. We added 1, and then we found we had the 2's complement of this original number. On to the next example. What is the 2's complement of the following binary number? I'll change the colour of the bits to make the visuals easier to follow. I will now convert all of the 1s to 0s and all of the 0s to 1s. We then have this as the original number and this as the 1's complement. 1 is then added to the 1's complement, and we can see this is 1 plus 1, which is 2, which means it is 0 down and carry 1. This is then 0 plus 1, which is 1. There are in effect all 0s here, so all these 0s are added in turn to the bits above, and of course it means that we effectively copy these bits to here. This is the 2's complement. So we start off with the original number, we find the 1's complement, we add 1 to the 1's complement, and we end up with the 2's complement. On to the next example. A quick method for finding the 2's complement of a binary number. Let's consider this binary number here. The steps involved are as follows. You start at the least significant bit and you copy that down. You then move on to the next bit and you copy that down. You then move on to the next bit and you copy that down. Now you can just see that I've copied down a 1. As soon as you copy down your first bit 1, you invert the rest. So we can see that this is inverted from a 1 to a 0, this from a 0 to a 1, and so on for the rest of the bits. And what we end up with is this being the original number and this being the 2's complement. To summarise, we look at these bits and we copy those down. We look at these bits and what we place down here is the inverse of those bits.